Most of the people learn binary search but still fail when asked about lower bound and upper bound. This happens in coding interview, lead code, code forces problem, and even while using STL in C++. They know that something exists in STL C++ and they don't even understand what that actually is. In this video, I will make you understand what lower bound and upper bound is. I will make these concepts so simple that after this video you will never confuse them again. If you know binary search already, then this video is going to be a upgrade for you and it will unlock new skill for you. So let's begin. Let's look at why our normal binary search will fail. Let's say you have this array 1 and 2 is present multiple times, and then you have 5 and 17. Well, array is sorted, correct? Yes, it is sorted in increasing order, so you can apply binary search. So let's say if they ask you what is the position for number 2, what you are going to return? Index 1, index 2 or index 3? Well, depending upon the implementation, it may return 1, 2 or 3. But what if I ask you specifically what is the index of first encounter of 2? Or if I ask you the very last encounter of 2, something like that, then their binary search is not going to work. Binary search can return any index based upon the implementation. That's why they introduce something called as lower and upper bound. So let's try to understand what lower bound is. Let's say this is the input array that we have. Lower bound of element x means that the very first index where the value of that index is greater than the value of x. So what is lower bound of 2? Where it's index 1, this value, right? Here we have greater than or equal to. So what is the first index that has value greater than or equal to 2? Well, this is not greater than or equal to 2. This is greater than or equal to 2. That's why we are returning 1. What about 3? Well, this is not greater than or equal to 3. This is not greater than or equal to 3. Not this, not this. This is the very first value, very first index that is greater than or equal to 3. That's why we are returning index 4. See, lower bound doesn't mean that element must exist. It only gives you a valid position, the very first valid position. I think this is clear, right? So what is upper bound then? Well, upper bound and lower bound have everything in common except you have here greater than and there you have greater than or equal to. So upper bound of x means that the very first index where the element is strictly greater than the value of x. So upper bound of 2 means the index 4. Why? Well, is this strictly greater than the value of 2? No. Is this greater than the value of 2? No. Is this greater than the value of 2? No. Is this greater than the value of 2? No. That's why you have index 4. 5 is greater than 2. Same thing goes for upper bound 3 as well. Value of 5 is strictly greater than 3. That's why index 4 is the answer. Upper bound doesn't mean that element must exist. It only provides us the first valid position where you have an element which is strictly greater than our input element. I hope this makes sense. Upper bound or lower bound are exactly the same. The only difference is element must be strictly greater than input element. That's the upper bound. And if it is greater than or equal to the input value, then that's the lower bound. Both of them find the very first index which satisfies the condition. Let's look at the example. So lower bound of 2 is going to be 1. Very easy to understand. While upper bound of 2 is going to be index 4. So if I subtract upper bound from lower bound, then I will know how many times 2 exist in the array. Simple as that, right? See, lower bound is greater than or equal to 2 and upper bound is strictly greater than 2. So lower bound will find the very first element where element is greater than or equal to 2, which is index 1. And upper bound will find the very first index where the element is strictly greater than 2, that is 4th index. All the elements in this particular range are going to be exactly 2. I hope this count is clear. Let's try to write the code. See, we have already seen how to write a binary search code. So I'm not going to deep dive and go into much more detail. But things are very simple. We have a low and high pointer to maintain where we are going to ultimately search. In binary search, we used to check whether the middle value is equal to our search element or not. If that is the case, we used to return. But here we are not returning, correct? If our middle element is greater than or equal to our input element, that means that particular middle element is a potential answer. But we still need to search on the left side because we need to find the very first index. This index is valid, that is good. But we need to find the very first index, so we need to search on the left side as well. That's why we are updating the value of high and making it equal to mid minus 1. If middle element itself is less than our input value x, then we need to search on the right side. And here we are updating the value of low. So it's very simple. Binary search is very simple. Everything else remains the same. The logic is how exactly are you going to update the value of answer and how exactly are you going to update the value of low and high. How exactly are you going to control your search space by updating the value of low and high. That's the main question in binary search. Binary search looks for the middle element and make a decision based on it. Same thing in upper bound as well. Very simple to understand. See, here you have greater than or equal to. Now in upper bound you will have strictly greater than. If middle element is strictly greater than the value of x, then this element is a potential answer. That's why we are updating it. But we still need to find the very first element. So you need to update the value of high so that our algorithm will search the answer into left side of our middle element. And if our middle element is less than or equal to the value of x, then we need to search the answer to the right side. And that's where we update the value of low pointer. I hope this makes sense. Lower bound and upper bound have exactly same code except for this condition. Simple as that. Time complexity is also we have already discussed, right? All the operations that we see inside a while loop are not dependent on the size of A, that is input array. We have addition, we have subtraction, we have division, we have assignment and if condition. So this entire thing will take O of one time for one time execution. The question is how many times we are going to execute this. So time complexity ultimately is going to be O of 1 into number of times code inside while loop will be executed. And you already know that code inside while loop will be executed till we reach length 1. We start from length n, then we go to n by 2, then we go to n by 4 and we end when our length is 1. This is log n base 2, correct? So final time complexity of lower and upper bound is going to be log n. Let's take an example for better understanding. Let's say they are asking us to find the lower bound for 2. So low is going to be 0. Here we will have low. Here we will have high. Remember, this low and high value we are using to control our search space. Initially, we are searching the answer into entire array. That's why low is pointing here and high is pointing here. Okay, so what will be the value of mid? Where is 2? So on the second index, you have element 2. You need to search for the lower bound of 2. That means you need to find the very first index where element is greater than or equal to 2. Now this value is actually greater than or equal to 2, right? This is exactly equal to 2. So what will happen? Well, we are going to update the answer. This could be the potential answer. But as the definition says, we need to find the very first index. Now this is a valid index, we agree, but we need to find the very first index. So we need to search on the left side. So we are going to update the high value. So now high will point here, which is mid minus 1 position, and low is still there. Now low is 0, high is 1, mid is going to be 0. At 0th index we have 1. Now 1 is less than 2. So we know for the fact that answer is not going to be in this section to the left side of mid. Mid is also pointing here, don't forget that. So we know that all the elements that are going to be left side of the mid are not going to be the answer. So what you do? We update the value of low. Simple as that, correct? So low will become 1 and high will become 1 as well. So mid value will be 1. Now we are at this index. Now this 2 is greater than or equal to the 2. So we will update the answer value. See, earlier answer was 2. 2 is also the correct answer, but the issue is lower bound tells us that we need to find the very first index, which is greater than or equal to 2. So this is not the very first index. That's why we kept on running our algorithm, and we ultimately found out that index 1 is the lowest possible index that has some value which is greater than or equal to 2. I hope this is clear. This lower bound and upper bound are already there in STL. Let's say this is a vector A and you apply lower bound. So to apply lower bound, you need to provide the starting index, the ending index and the value, right? Same thing goes for the upper bound as well. You need to provide starting index, that is starting pointer ultimately, ending pointer and the value. This lower bound and upper bound, both of them will return the pointer. to the answer. To find the exact index, you need to subtract the initial pointer. So lower bound is going to return the pointer for this. To know the index, that is going to be the first index, you need to subtract the value of very first element of the vector, correct? So you get LB value as 1 and UB upper bound value as 4. We need to be very certain that array is going to be sorted to apply binary search, to apply lower bound and upper bound. Mistake 2 is that programmers usually get confused between greater than or equal to and just greater than, strictly greater than. This is lower bound and this is upper bound, correct? Mistake number 3 is people usually forget to convert iterator to index. So what they do, they directly use this lower bound and they don't subtract the beginning. So never forget to subtract this value.